Reducing range anxiety. How new tech is transforming EV experiences. Range anxiety, or the dread of running out of battery power before arriving at a charging station, is still a major concern for prospective owners of electric vehicles as their popularity grows. But technological developments are changing the EV scene, making owning and driving an EV simpler and more convenient. In this video, we will highlight 7 key ways new technology is reducing range anxiety and reshaping the future of electric mobility. Number 7. Artificial intelligence integration. By offering a range of clever solutions that improve user experience and operational efficiency, artificial intelligence is radically changing the electric car market. Large datasets such as past driving habits, charging station locations, user preferences, and current traffic circumstances are analyzed by AI systems using machine learning techniques. For instance, depending on a driver's usual itineraries, AI can forecast when they will likely need to charge and recommend the best charging stations along the way. Users can save money by using this predictive feature to suggest charging periods that coincide with cheaper electricity rates. In order to make sure drivers are informed about their trip, AI-driven navigation systems can also combine traffic and weather data to generate dynamic route recommendations that include charging stations. Some sophisticated AI systems also provide notifications when battery levels fall below a predetermined point, encouraging users to schedule their next charging stop in advance. By offering these customized insights and suggestions, AI not only improves convenience but also boosts EV drivers' confidence, reducing range anxiety and facilitating a more seamless transition to electric mobility. Number 6. Ultra-fast charging technology. One of the biggest obstacles to EV adoption is charging time, which ultra-fast charging technology addresses with a huge advancement in EV infrastructure. With the help of these cutting-edge charging stations, which have power outputs of over 350 kWh, an electric car can be charged from empty to about 80% full in as little as 10 to 15 minutes, which is about the same amount of time it takes to fill up a conventional gasoline car. Because it allows drivers to stop quickly on road trips without experiencing significant delays, this rapid charging capacity is essential for long-distance travel. Ultra-fast chargers are positioned strategically in urban areas and along key highways to guarantee that EV owners have access to dependable charging choices when they need them most. To further improve accessibility, a lot of UFC stations have multiple charging connections that let numerous cars to charge at once. The overall charging infrastructure will grow more resilient as battery technology advances and more automobiles are built with ultra-fast charging capability. By making electric vehicles a viable choice for daily use, this advancement not only reduces range anxiety, but also promotes increased acceptance of these vehicles. Number 5. Battery swapping solutions. By enabling drivers to swiftly swap out their drained batteries for fully charged ones at designated stations, battery swapping technology presents a new alternative to conventional EV charging techniques. Compared to traditional charging techniques, which can take several hours or longer, this process usually only takes a few minutes. In places like China, where a network of battery swapping stations has been set up to serve their fleet of electric vehicles, companies like NIO have been at the forefront of this approach. Concerns regarding battery degradation and maintenance are reduced when battery ownership is transferred from individual users to service providers. By using centralized monitoring and maintenance procedures, service providers may better control battery health. Better battery lifecycle management is made possible by this centralized method, which guarantees that batteries are charged to their full potential and recycled appropriately after their useful lives are over. Drivers may access charged batteries regardless of the brand or type of their car, because to the standardization of battery packs across various vehicle models, which also improves compatibility and user convenience. In addition to addressing range anxiety by making charged batteries quickly accessible, this strategy promotes sustainability by making battery recycling and reuse simpler. Number 4. Wireless charging. By completely doing away with the need for physical connectors and cords, wireless charging technology is revolutionizing the way electric vehicles are recharged. By using inductive charging pads that are buried in parking lots or roads, EVs can be charged just by parking over them. The driver does not need to do anything. This technology is especially useful in urban settings with limited space, since it offers a user-friendly interface and seamless connection with current infrastructure. Wireless charging, for example, might be very helpful for commercial applications like ride-sharing services or public transit systems. Drivers would not have to physically plug in or unplug chargers while waiting for their cars at specified stops or depots. Furthermore, some systems provide dynamic wireless charging, which lessens the need for static charging stations and improves ease for long-distance driving by enabling cars to charge while traversing electrified portions of the route. Drivers will not have to worry about locating conventional charging stations or handling bulky cables as wireless charging infrastructure expands and may even be included into smart city plans. A wider range of people may find electric vehicles more appealing as a result of their smooth integration into daily life. Number 3. Vehicle-to-grid technology. Vehicle-to-grid technology creates a two-way energy flow that helps both EV owners and the electrical grid by enabling EVs to both use power from the grid and return excess energy when needed. This creative method turns EVs into portable energy storage devices that may provide electricity during times of high demand, when costs are usually higher. This essentially turns EV owners' cars into assets that generate income while they are parked or not in use, offering them possible financial incentives in exchange for energy returned to the grid. Furthermore, by serving as a buffer during variations in energy supply and demand, V2G greatly enhances grid stability. This is especially crucial as renewable energy sources like wind and solar power are further incorporated into power networks where generation can be erratic. V2G technology addresses more general issues about energy consumption and sustainability while providing this dual capability, which improves the entire value proposition of owning an electric car. V2G systems will be essential to integrating electric vehicles into future energy systems and fostering a more resilient and efficient energy landscape as they evolve further, aided by developments in smart grid technology. Number 2. Electrified roads. The idea behind electrified roads is to embed conductive materials in the road so that cars can charge on certain stretches of the road while they are parked or driving. Because electric vehicles could continuously recharge while traveling instead of depending only on static charging stations at predetermined times along routes, this novel technology could significantly reduce range anxiety by enabling smaller battery packs in electric vehicles. This technology is being investigated in pilot projects worldwide. For example, Sweden has installed electrified roads that use overhead lines akin to those found in tram systems or conductive rails buried in the pavement to power buses and trucks as they go along specified routes. In addition to lowering the number of stops required for recharging, this might result in lighter cars with smaller batteries, which would increase efficiency and lower costs for both manufacturers and users. Additionally, by connecting with public transit systems and lowering overall emissions from fossil fuel-powered automobiles on the road, electrified roadways may provide more environmentally friendly urban mobility options. Number 1. Enhanced public charging infrastructure. Large sums of money are being invested in developing public charging infrastructure in many parts of the world in order to accommodate the growing number of electric vehicles on the road. In order to ensure accessibility for all EV owners regardless of their location or lifestyle needs, governments at all levels, federal, state, and local, are working with private companies to install more charging stations at key locations like urban centers, highways, shopping malls, workplaces, residential areas, and even rural areas, repurposing existing gas station locations into EV charging hubs with fast chargers that can swiftly recharge batteries while drivers take breaks or shop nearby is one creative solution. Some stations even provide amenities like coffee shops or lounges where drivers can unwind while charging. Furthermore, mobile apps that offer real-time information on station availability, pricing options, user reviews and capabilities at select locations, giving users the peace of mind that they have secured access before arriving at a station, are making it easier for users to locate chargers, thanks to advancements in payment systems. As consumer interest in electric mobility continues to grow rapidly across demographics, the increased availability of public chargers not only makes it easier for EV owners to find convenient places to recharge, but it also boosts confidence among potential buyers who may be hesitant due to concerns about range limitations or accessibility issues related to long-distance travel planning. Together, these developments seek to establish a strong ecosystem that encourages the use of electric vehicles and resolves common issues like range anxiety, ultimately paving the way for a more sustainable transportation future in which electric mobility becomes a necessary component of daily life. If you liked our video, please hit the like button and subscribe to our YouTube channel.